So we'll review some derivative at a point problems, some harder ones from the homework. And then we're going to move on to section 3.2, derivative of function. So that would be f prime of x. And the more common definition is the h version, which would be the limit as h goes to 0 of f of x plus h. So instead of plugging in a number like 2 or 5 for x or a, we're going to leave the x there and see what happens. And I just want to make a note on that. Alternatively, we could still use the limit as x approaches a of f of x minus f of a over x minus a. And if we use that method, we leave x and a and not plug in any numbers, like x equals 2 or a equals 2. Right. So we'll do a couple of the point versions, and then we're going to move on to those versions today. And I'm going to, a few people sent me, they got stuck on question 5, so let's do that one, and then we'll see what other ones were asked about. I'll give you a minute. Write these formulas down. This is what we want to master.
Those are very similar.
They're very similar. Yeah, the only difference, and it does make a big deal, instead of plugging in a 2 for a, we're not going to plug in any numbers right away with the second method, which does make it significantly harder. Yeah. Well, the derivative of function. Yeah, not having a number for a makes it a little trickier. We got more work to do, just the way it is. But it's not too much different. Same idea. All right, so this would be, let's see, homework 3.1, number 5. And there's a few different versions of it, but they look something like f of x equals some number over x squared. And then you were given a equals some number. So maybe I'm going to pick 3 over x squared and a equals 5. And I think this version didn't say to use the h method or the x minus a method. Does anybody want me to pick one for them? What do you want to try?
Do it different.
The h method, or you can't use shortcuts. You got to use the limit. So you have to use, so if this question was on the test, you've got to show me the work for either this or that. You can't use the shortcut you might have learned in a previous calculus class. That's the next test. So you probably rewrote it as like 3x to the negative 2, and then use that shortcut rule with no limits. Okay, not legal here yet. Sorry. Okay, so which one do we want to use? The x minus a method or the h method? H, let's do h method. Okay. And with the h method, I usually break it down in 3 parts, but you could do it all in one. Do you want me to do the in parts or all at once? Parts? Okay, I'm going to write down the problem and then I'll break down the parts. So what I want to do is find f prime of 5. And that's going to be the limit as h goes to 0 of my function. I'm going to write a function first, then I'll plug into it. The function evaluated at 5 plus h minus the function evaluated at 5. And I want to divide by h. So if I do the all at once method, that becomes the limit as h goes to 0 of 3 over 5 plus h squared minus 3 over 5 squared all over h. The doing it in pieces method is to first calculate the f of x plus h, and second, do the subtraction, third, divide by h, and then the fourth step would be to do the limit. And I'm going to do this all at once, and then we could break it down in parts after if you want. since this one didn't ask for the pieces. So in order to deal with this, if I just plug in h equals 0, I'm going to get 0 over 0. That always happens the first time. So I got to do some algebra on this. And the only algebra I can really do is to deal with this subtraction right here, which means I need a common denominator. And the common denominator is just the product of those two denominators. No way around it. So next, I would write down, I have the limit as h goes to 0, big ass fraction, h in the bottom. My numerator then, this one has to be multiplied by 5 squared over 5 squared. So that's going to give me 3 times 5 squared. This one has to be multiplied by 5 plus h squared, top and bottom. So that's going to give me a minus 3 times 5 plus h squared. And my common denominator here is 5 squared times 5 plus h squared. And there's my, make that other fraction bar bigger. And I missed a parentheses right here.
Wait, you don't want us to factor in that. 5 plus h, or not, what is it?
In the numerator, I am going to have to multiply, I'm going to have to do the square in the numerator. Yeah.
Okay.
So that's what I'm going to do next. And that's why sometimes it's nice to do it in parts. Otherwise, you're writing reproducing a lot of stuff you don't need to reproduce.
Yeah.
So limit as h goes to 0, big fraction over h. Okay, so let's see. 5 squared is 75 times 3, sorry, 25 times 3 is 75. I got a little ahead of myself. So I'm going to have a 75 here. Minus, if I multiply 5 plus h times 5 plus h, I'm going to just do that off to the side here. 5 plus h times 5 plus h. You can't shortcut that. That's going to be a 25 plus a 5h plus another 5h. Yeah, 10h plus h squared. And we need to multiply that by 3. So I'm going to have a minus 75 minus 30h minus 3h squared.
So if, cause I found like most of the problems, like the 75, they would cancel.
Yeah, yeah, and these, that the constant's always going to cancel. Yeah.
So if they don't,
If you don't, yeah, if you don't, something went wrong. And then this is my inner denominator. And then again, nice things are happening. The 75 minus 75 goes away. Okay, then I have what's left, a minus 30h minus 3h squared. That factors a little bit. So what do I have next?
take out a 3h.
Yeah, factor out a 3h. So in the numerator of the numerator, we've got a 3h pulled out. Oh, negative 3h, correct. There should be a negative 3h. Good job. And then 3 goes into 30 10 times. And 3 goes into 3 once. There's an h left, so it'd be 10 plus h. Okay, what can I do with this? Well, I have an h in the upper numerator and an h in the very bottom numerator. So if you don't realize those cancel, you could rewrite this as the limit as h goes to 0 of negative 3h times 10 plus h over 5 times 5 plus h squared. And instead of dividing by h here, I'm going to multiply by 1 over h. Then it's more obvious that these h's divide out. That's an h, not an n.
Negative 3h.
Yeah, so then the question is, at this point, am I safe to plug in h equals 0?
Yeah.
So if I plug in h equals 0, what am I going to get? So let's check. I'm going to get a negative 3 times 10 plus 0 over 5 times 5 plus 0 squared, which is negative 3 times 10 or negative 30 5 squared is 25 times 5 is 125. Yeah.
What happened to the square on the 5?
Oh, did I lose that square? Yep.
Oh,
Yeah, I lost it from here to here. That should be a 5 squared.
25 times 5.
So that's a 5 squared. So I'm going to have a 5 squared times a 5 squared, which is 625.
Yeah.
And then this should reduce sometimes. This one does. 5 goes into top and bottom. -6 over 125.
Yeah.
Okay. Whoa, that was tough. Did I do it right?
Yeah.
I don't know. I could have screwed this up. I make mistakes all the time. How can I check it? Yeah, you're gonna have to graph the tangent line and see if it looks tangent, or do it a different way. Like I could try the x minus a method and see what happens. So actually, I'm gonna do it that way instead. Let's see if I get the same answer. Yeah, see if I get the same answer. So I want to try to find f prime of 5 for f of x equals 3 over x squared. And I'm going to use the other definition, limit as x approaches 5 of f of x minus f of 5 over x minus 5. And so plugging all my stuff into that, limit as x approaches 5, f of x is just 3 over x squared. F of 5, 3 over 25.
Yeah.
And on the bottom, I have an x minus 5. I got to do no common denominator here. So basically, the key when there's no common denominator, it's kind of a crisscross cross thing. So that's going to give me 3 times 25, which is 75, minus 3x squared over 25x squared. You see how I'm getting that?
Yeah.
Okay. And that is all over x minus 5. And this is important. When you have a fraction within a fraction like that, you got to keep track of which the main fraction bar, the bigger one. Okay, so I always make that one bigger. Limit still hanging out, not ready to deal with it yet. Okay, what can I do next? Well, dividing by something is multiplying by the reciprocal. So I could, let's use a different color, take this out and multiply by 1 over x minus 5. Right? Dividing by something with fractions is multiplying by the reciprocal. So I'm multiplying by the reciprocal of x minus 5, which is 1 over x minus 5. Okay, nothing's canceled yet. What should I do next?
Well, I just plug in 5 at this point.
Yeah, if we plug in 5, I'm going to get a 1 over 0 here. And then I'm going to get a 0 up here, so I still have 0 over 0. I'm multiplying, I don't need a common denominator. Yeah, this 75 minus 3x squared factors. Okay, so off to the side, I'm just going to make, I'll just write it down here. What can I factor out of 75 minus 3x squared? A 3. So that's going to give me a 3 times 25 minus x squared. 25 minus x squared factor?
That's just
It's a difference of 2 squares. Yeah, so that's 3 times 5 minus x times 5 plus x. Okay, so what I have is that over 25x squared times 1 over x minus 5. Limit of that. X minus 5 versus 5 minus x. Almost, they're opposites of each other.
-1.
Yeah, so they factor, they cancel out as a -1.
3.
So
-3.
this divided by this is -1.
-1 times that.
Okay, what if I plug in 5 now? I don't get any zeros.
Yeah.
So if I plug in 5, I'm going to get a 3 times 5 plus 5.
-3.
Yeah, I'm gonna write just times -1 there, because the way I wrote it there, or you could call it a -3, over 25 times 5 squared. Let's see, 5 plus 5 is 10, times 3 is -30, over 625. Same thing we got before. I like this method better, holy crap.
Then that was a little bit easier.
Yeah, and again,
The A method.
historically, I don't know why the H method got more popular. I like this one better more than half the time.
Well,
Yeah, they had us do the H method on here.
There's some of them I forced you to do it because it's more popular. I'm sorry I forced you to do it, but it is more popular. Again, more than half the time, I like this method better. I don't know what else to say about it.
I feel like it's a lot more mistakes can be made easily with that.